1919, Sir Arthur Eddington mounted expeditions to Brazil and Principe Island to see if starlight near the sun really curved the way Einstein's general relativity predicted. A reporter cornered Einstein. "What if Eddington's results contradict your theory?" Einstein famously shot back, "Then I shall pity the Lord God, since the theory is correct anyway."
Perfect.
Sure, maybe that was partly ego. He'd poured his soul into this theory and wasn't prepared to see it fail. But that's not the core point. Einstein's theory had a quality so compelling that many physicists embraced it before the experimental test. Einstein was so enamored by his theory's elegance that he couldn't fathom it being false. Of course, the results agreed with relativity, and no one lost. But note well, Einstein had worked himself into believing that pure thought alone could unmask nature's laws. I am convinced that through purely mathematical constructions, we can find those concepts and the regular relationships between them, which will give us the key to understanding the phenomena of nature. I therefore believe, in a certain sense, that the belief of the ancients that pure thought is able to comprehend reality is justified. Now think back to your school days. You've probably got that stale phrase burned into your brain. In a right triangle, the square of the hypotenuse equals the sum of the squares of the legs.
Come on, man.
Maybe that triggers mild nausea, or maybe you can't recall what it even means, or you've already slammed the close button. But here's a shocker. Pythagoras, the theorem's father, had a full-blown religious ecstasy over this result. Legend says he was so shaken by the discovery he broke his own vegetarian vow and sacrificed 100 bulls. So the old adage still applies. All for the claim that if you build squares on a right triangle's 3 sides, the big square's area equals the sum of the smaller squares. If you could hear it the way Pythagoras did, you'd realize something mind-blowing. Apparently, in this messy, chaotic cosmos, the geometry of real stuff still harbors crisp numerical patterns. Frank Wilczek, a Nobel Prize-winning physicist, poses a question in a beautiful question that might sound insane for a scientist. Is the world a work of art? Our question seems most natural within the framework of a spiritual cosmology. If a strong and powerful creator created the world, it is possible that he or she or they or it was guided by the desire to create something beautiful. Wilczek ends his book by answering his own question with an unflinching yes. The psychologist Irvin Yalom once identified meaninglessness as one of humanity's 4 existential terrors, alongside death, isolation, and the burdens of freedom. Turns out, chasing this sense of deep meaning might drive people not just to religion but also to science. Beauty is what invests life with meaning, but it can also tempt scientists to project fantasies onto reality, protecting them from the stark facts. That, says Sabine Hossenfelder, German theoretical physicist and quantum gravity specialist, is a major reason we haven't seen real breakthroughs in theoretical physics for over 40 years. She lays it bare in her book, Lost in Math. We might be allowing our craving for beauty to overshadow the brute demands of data. This book practically spits in the eye of Wilczek and many other theoretical physicists. Russian astronomer Vladimir Surdin called it a knockout punch to anyone who thinks a beautiful theory always nails reality, and believe me, hordes of people believe that. This problem is huge, far bigger than you might imagine. The book itself isn't exactly a breeze if you're just a curious layperson. Big chunks flew over my head, but I caught the main drift. The author's stinging jabs at colleagues are almost an art form in themselves. No wonder it's a bestseller, translated into 10 languages. Lost in Math uncovers a staggeringly weird and deeply serious dilemma that, per the author, nobody seriously addressed before. It took 25 years for neutrinos to go from theory to discovery, 50 for the Higgs boson, and a century to detect gravitational waves. Now, testing a brand new fundamental law might outlive any scientist's entire career, so the theorists started going nuts. The sense of beauty of a physical theory is as if it's built into our brains. It's not a social construct. It strikes some inner string. When you come across a beautiful theory, you have the same emotional reaction as you do in front of a work of art, says Francesco Giudice, an Italian theoretical physicist at CERN. I've checked out a bunch of definitions of beauty, and guess what? We basically have no clue what it even is, yet we instantly sense it whenever it hits us. Why would certain math laws of the universe spark pleasure in a bunch of apes like us? Bullshit, right? We're just animals. As geneticist Theodosius Dobzhansky famously said, nothing in biology makes sense, except in the light of evolution. But somehow we see theorems, formulas, and cosmic hypotheses as beautiful. That's insane, considering human knowledge of fundamental laws is brand new in evolutionary terms. We had to build microscopes, telescopes, and monstrous math arguments to get here. It's not like math is programmed in our genes. Yet it's undeniable that our sense of beauty resonates with nature's bedrock. Some mind-matter mystical alignment, perhaps? Could it be a taste of something divine? The imperfection of the world rests only on the fact that we know too little of the universal harmony of the universe and the hidden grounds of God's activity, wrote Gottfried Leibniz, German philosopher, physicist, mathematician. Take it or leave it, that viewpoint lingers. Since 1995, divers in the Sea of Japan have found stunning 2-meter-wide circular sculptures carved in the sand. For nearly 20 years, nobody knew what was making them. Turns out, brace yourself, they're crafted by a tiny male white-spotted pufferfish. He adorns his nest with shells and coral, respecting perfect symmetry. He spends about 8 days building his subaquatic architecture. And why does he do this? To woo the ladies. The visiting female judges his spiral masterpiece, and if it's good enough, she consents to mate. Imagine that. A 10-centimeter fish with a pinprick brain is orchestrating near mathematical elegance. So, for that species, building a symmetrical sculpture is the key to sexual success. And that's where beauty takes on a downright mysterious vibe. Physics is extremely successful. It's near impossible to point at anything in everyday life that isn't shaped by its triumphs, because physics nails reality at a fundamental level. Well, sort of. Our current universe model is so complete, it can send rockets flying and split atoms, yet at the same time it's incomplete, covering just 4% of the universe's matter. What's the other 96% made of? We have no clue. The most shocking revelation is that the main source of gravity out there has nothing to do with anything we've ever encountered. This mysterious energy, dubbed dark energy, makes up a staggering 68.3% of the total energy supply of matter. All we know is that it accelerates the universe's expansion. Another reason we can't detect it nearby? It's spread so thin that only across vast cosmic distances do we see its effect in that accelerating expansion of space. And there's more. 26.8% of the universe is filled with yet another curveball, some brand new type of matter we've never encountered, called dark matter. All we know is that it barely interacts with itself or anything else, especially no interaction with light. So a more honest name might be transparent matter, but dark is catchier. Only the last 5% is the stuff we actually know, the matter that makes up you, me, and everything else we see. That 5% is explained by the Standard Model, the best, most universal theory for the microcosm. Well, again, sort of. 5%. It's terrifying to realize we truly understand just 5% of what's out there. So, humanity embarked on one of its greatest gambles ever. Over 10,000 scientists and engineers from more than 100 countries funneled over $10 billion into one mega project, the Large Hadron Collider. This thing costs about 30 times the Vatican's annual budget and yields zero profit. Everyone has heard of it. Few know why it exists. The researcher, in his efforts to express the fundamental laws of nature in mathematical form, must chiefly aim at mathematical beauty. Paul Dirac, English theoretical physicist, quantum mechanics pioneer, Nobel laureate. Yes, we might only grasp 5% of the universe, but damn it, we're chasing mathematical beauty anyway. If that's not the perfect paradox of modern science, I don't know what is. How the hell do female birds of paradise end up with such insanely elaborate taste and aesthetics? It's a total enigma. And yet, for me, the real mind-bender is their plain-looking cousin, the male bowerbird. Far less flashy, but what it creates is off the charts. The male bowerbird builds a mini hut with carefully constructed entrances, arches, vestibules, and even footpaths leading up to the front door. Then he meticulously arranges bunches of flowers, color coordinates berries, and stacks white mounds made of shell or bone. And that's just the tip of his design iceberg. The male actually paints his structure with berry juice, using a leaf or bark shred as a brush.
Perfect. Everything, down to the last minute details.
If you mess with even a single berry, he'll freak out, rushing to restore his masterpiece with the precision of a micromanaging painter. Different bowerbird species build different kinds of huts. Fascinatingly, individual birds within one species can develop their own personal style. And here's the crazy part. These elaborate huts serve no practical function. They're not used as nests, they don't shelter from weather, they can't incubate eggs or raise chicks. Nope. It's just a stupid art installation with one sole purpose: to blow the female's mind.
Yeah, baby! Yeah.
That's it. But why the hell does beauty in a potential mate's creation matter so much to these females? Why is it the deal breaker for them? And more bizarre yet, we humans think these avian artworks are gorgeous too. We like to imagine all our fancy human arts are purely cultural, but a ton of our aesthetic sense obviously overlaps with other species, meaning it can't just be cultural. Coincidence that we adore flowers, which actually evolved to seduce bees, not us. Of course, it's not like our brain directly came from a bee's, but both species apparently stumbled on the same universal aesthetic triggers. That's why a peacock's tail also dazzles us, even though the flamboyant feathers are strictly meant to impress peahens, not Homo sapiens. But here we are, so infatuated by their sparkle that we'll literally stick those feathers in our hats. In my work, I always try to combine truth with beauty, but when I had to choose one or the other, I usually chose beauty. Hermann Weyl, German theoretical physicist and mathematician. The standard model might be successful, but oh boy, is it ever ugly. Even among physicists, it gets no love. Michio Kaku calls it ugly and contrived. Stephen Hawking dismissed it as ugly and random. Matt Strassler brands it ugly and ridiculous. Brian Greene grumbles it's too flexible, and Paul Davies thinks it reeks of unresolved issues, like the messy way it merges electro-weak and strong forces. Sabine Hossenfelder says she's still looking for a single physicist who likes the standard model. If you're wondering why, well, the biggest sin of this theory, which, just to remind you, describes all known elementary particle interactions, is that it's, get this, unnatural. Yep, you heard me, unnatural. Look up naturalness in physics on Wikipedia, and you'll find that unnatural basically means too weird, or no obvious reason for these weird values. Imagine a model needing 4 parameters to nail certain real-world predictions. Then experiments reveal those 4 numbers are 1.2, 1.31, 0.9, and wham, 4 times 10 to the 29th power. You'd be like, what the fuck is that? 3 near 1 and 1 insanely huge? That's so wrong, unnatural, and definitely not cute. That's the standard model's parameters for you. Theoretical physicist Matt Strassler deems the standard model an extremely improbable, unnatural theory, among the most unnatural in physics by his account. Though the universe's existence under that weird setup looks a bit like the old days, when people assumed the solar system was unique, and astronomers tried to force some natural geometry behind planet spacing. Kepler thought God's creation had a Platonic geometry, like the planet's orbits were linked to the 5 Platonic solids, which themselves are these symmetrical 3D polyhedra. Plato had argued in Timaeus that all material things come from 4 such solids, with the 5th, the dodecahedron, matching the universe's shape. That's probably why Salvador Dali used a dodecahedron in the Sacrament of the Last Supper, and folks have known about these shapes at least 1,000 years before Plato. There's a set of carved stones in a museum at Oxford that might be the oldest evidence. But anyway, Kepler's idea that these solids explained planetary orbits crashed and burned once we realized there are countless planetary systems. At the same time that the countless planetary systems, there's nothing natural or unnatural about Earth's distance from the Sun. It's just random. According to Sergei Trotsky, a leading researcher at the Institute of Nuclear Research of the Russian Academy of Sciences, in a Tech Insider article, the Standard Model is arranged in a very ugly way. It contains 19 numerical parameters, which are determined by experiment and, from the point of view of common sense, take very exotic values. For example, the vacuum mean of the Higgs field, which is responsible for the masses of elementary particles, is 240 giga-electron volts. It is not clear why this parameter is 1017 times smaller than the parameter defining the gravitational interaction. The Standard Model does not explain the huge difference between the masses of the lightest quarks, of which are composed of protons and neutrons, and the mass of the true quark, which exceeds 170 giga-electron volts. In all other respects, it is no different from the top quark, which is almost 10,000 times lighter. Where seemingly identical particles with such different masses come from is still unclear. You could say, well, a divine creator fiddled with the universe's parameters so we'd get the world we know. But who's satisfied by that line? Another fallback. Maybe there's a multiverse of universes, each with its own parameter set, and ours just happens to produce us. That could be valid. But how do you test it? So some find that explanation unsatisfying, others are convinced there must be a deeper system, something that ties all this chaos into one coherent package we haven't seen yet. Werner Heisenberg, the quantum mechanics pioneer, put it like this: when nature itself suggests mathematical forms of great beauty and simplicity, one is forced to believe that they are true, that is, that they express real features of nature. Take a look at this image. At first glance, just chaos. Then your brain does its thing and bam, everything clicks into place. It's performing the mission it evolved for, piecing together the puzzle and rewarding itself with a tiny dose of pleasure. You might not even notice it, but when you suddenly see a Dalmatian sniffing the ground, you get that little aha jolt. Gestalt psychologists pinned this law of grouping a century ago, and both artists and fashion designers exploit it constantly. Check out famous Renaissance paintings. The same azure blue tone repeats across halos, clothes, hair, scattered but connected by color. The painter uses a limited color palette because they know your brain craves that grouping. Same principle in fashion. When someone buys a red skirt, a savvy sales clerk suggests a matching red scarf. And almost every man buying a tie knows that it will be cool to match it to the color of his eyes. This law of grouping points to something super deep in the brain. Why do we have this bizarre, computationally heavy skill? It evolved to crack camouflage, spot real objects in chaos. If I ask you, why do we have vision? You might say, to behold the spectacle of existence. Very poetic, but let's be real. Vision evolved to let us detect, avoid, chase, devour, or mate. Think of your ancestors seeing a picture like this. In a split second, their brain conducts the following monologue. What is the probability that all these fragments of the same color are all pure chance? Let it better be zero. It's not much of a chance. Yes, let's assume that they belong to the same object. So I'll glue them together. Oh, I think I have to run. Spotting patterns literally meant life or death. And guess what? When we color coordinate outfits, we're basically applying that same fundamental predator detection principle. Beauty is the road to knowledge, or rather, the only knowledge worth possessing, said astrophysicist Edward Arthur Milne. Physicists tried to do exactly that, to see the Dalmatian in reality. They extended the Standard Model into something they call supersymmetry, giving it the usual reverent label, beautiful. Supersymmetry looks far more natural and solves a raft of modern physics headaches. Its math is often handy in various physics realms, but so far, in practice, it's just gorgeous equations on paper. That $10 billion collider built in large part to confirm supersymmetry didn't find squat, despite physicists' super-confident predictions. Back in 1930, Wolfgang Pauli proposed a new particle, the neutrino, to explain why radioactive decay seemed to lose energy. He called it a desperate remedy, and confessed to astronomer Walter Bade, "Today I have done a terrible thing, totally unacceptable for a theoretical physicist. I have put forward a hypothesis that can never be confirmed or disproved experimentally." Ever since Wolfgang Pauli tossed out his neutrino guess, a desperate remedy in his own words, particle postulation has become a favorite pastime for theorists. We've got preons, sphermions, dions, simps, wimps, plus all sorts of non-particles. None of them have ever been seen, but thousands of papers detail their properties. Sabine Hossenfelder argues that physicists have gone wild with outlandish theories, and in her 20 years in theoretical physics, she's watched plenty of folks build careers on pure speculation, stuff nobody's observed.
Wait a minute!
Her snarky summary of the typical tactic: just claim your hypothetical particle needs so much energy to be produced, we can't reach that level, or it interacts so rarely that our detectors aren't sensitive enough, or both. The prime example, dark matter. The big fallback is always, it must be some undiscovered particles, though no one said dark matter has to be particulate at all. We've already found galaxy patterns that standard particle-based dark matter can't explain, like how our Milky Way's satellite galaxies are strangely lined up in a plane, or why there are fewer of them than the theory predicts. Possibly we're missing astrophysical processes in our models, or maybe we're missing a bigger conceptual point. The elephant in the room is, have we reached the limits of testability? Maybe confirming certain theories would require a collider the size of Jupiter, orbiting a neutron star, or some equally insane contraption. According to Hossenfelder, that's what we'd need to detect the hypothetical graviton. So what if we can't test our mind-boggling ideas at all? Deprived of this opportunity to spin the wheel of science, some theoretical physicists have invented their own method of evaluating theory. Betting. Cosmologist Martin Rees bet his dog that the multiverse exists. Andre Linde has his own life, and Steven Weinberg is confident enough in the multiverse to vouch for it with the lives of both Andre Linde and Martin Rees's dog. Speaking of Weinberg, the same Weinberg who once said that talk of curved spacetime and general relativity is just fluff, that only predictive power matters. David Deutsch in The Fabric of Reality slammed that instrumentalist stance, implying Weinberg might be missing a deeper motivation. Seems Deutsch might have been onto something. Weinberg co-invented the Standard Model and apparently hungers for a neat cosmic story, even if it's untestable or makes zero predictions. George Ellis, professor emeritus at the University of Cape Town and a huge name in cosmology, points out that some physicists now openly suggest we don't need to verify their theories at all because they're good enough.
You serious?
He warns that relaxing the verification standard could rewind science by 1,000 years. But what if he's wrong? Why shouldn't we claim there's something in our minds that can lead us straight to truth without experiments? Who says all knowledge must come from experience? Are we absolutely sure we have zero built-in knowledge about reality? Why are we so certain Einstein was mistaken when he insisted mere thought can unveil nature's laws?
Bullshit!
Let me quote Einstein more fully. All previous experience convinces us that nature is a realization of the simplest mathematically conceivable elements. I am convinced that through purely mathematical constructions we can find those concepts and the regular relationships between them which will give us the key to understanding the phenomena of nature. Experience may suggest to us the corresponding mathematical concepts, but they can by no means be deduced from it. Of course, experience remains the only criterion for the suitability of mathematical constructions of physics, but the real creativity is inherent in mathematics. Therefore, I consider in a certain sense justified the belief of the ancients that pure thought is able to comprehend reality. Which ancients was Einstein talking about? In his dialogue Meno, Plato gives a powerful demonstration of knowledge existing before any experience. Socrates questions a young slave boy with no geometry training, and the kid, without any hint, winds up re-deriving Pythagoras' theorem by pure reasoning. Think about that. How does someone who knows zilch about geometry latch on to correct intuitions about geometric figures? That begs the question, what the heck are geometric shapes anyway? Why can every human get them without issue?
what do we have?
If we're talking about evolution, geometric forms aren't exactly plastered all over nature. You see a pyramid on Mars, you'd freak, right? No one would call that natural. Or that weird hexagon on Saturn's pole, still puzzling us. It's easy to explain why, from an evolutionary point of view, we call such a landscape beautiful and why it makes us feel good. Water, sunshine, trees, etc. Stuff that helped our ancestors survive. But how do we explain why we like this or this or this?
Just stop.
We believe that nature is best described by equations, as simple, beautiful, compact, and universal as possible. Leon Lederman, Nobel Prize-winning physicist. We admire grand ancient structures and forget we're seeing only the survivors, most collapsed, often soon after completion, especially the bold, innovative ones. Because the ancient architect had only partial knowledge, gleaned from practical experience. That knowledge was real enough to build something, but it wasn't stripped down to its mathematical or physical core. So they couldn't have spelled out the fundamental principles in formulas and probably couldn't say for sure why a certain design failed.
Oh boy.
If 1,000 people read a book, they will read 1,000 different books. But if 1,000 people read equation, they will read the same equation. Math is purged of all the fluffy junk, pure essence. That's why these days it's rare for a structure to collapse from poor design, even if it's an insane new shape no one's tried before. Our refined knowledge means we can erect skyscrapers and space stations the ancient builders never dreamed of. Modern builders grasp the universe's engineering principles so deeply, they can apply them to any structure, with any material, in any environment, be it the moon, underwater, or some Martian wasteland. And if you think I've been spewing disjointed nonsense, well, first off, thanks for sticking around.
Oh, hey, no problemo.
And second, I'm driving at the point that we intrinsically have this ability to detect patterns, to push through the noise and find the core of phenomena. And we love doing it. All those points, segments, triangles are how our minds chunk matter into simplest building blocks, the simplest shapes matter can take. Try to name a closed rectilinear figure simpler than a triangle. You can't. By cracking the rules these simplest blocks follow, we can decode bigger macro systems built from them. We're essentially trying to corner the essence of reality. And guess what? It's not just us doing it. Animals do too.
Rico, we'll need special tactical equipment.
Picture an experiment. A rat is trained to tell a rectangle from a square. Approach the rectangle, it scores cheese. Move toward the square, no cheese. After a bunch of tries, it nails the pattern. Rectangle equals reward. Now here's the punchline. If you offer the rat a second rectangle that's even longer and thinner than the original, it prefers that new rectangle over the old one. The rat's not dumb. It zeroed in on the essence, the regularity. That more extreme rectangle is even more, well, rectangly. The bigger the contrast from squarehood, the better. Grabbing the core pattern is an evolutionary plus. So, no shock, it's satisfying.
Right.
Maybe we like geometric shapes because they're the most basic geometry we can conceive, at least from our human vantage point. Maybe that's also why we love caricatures so much. Have you ever thought how insanely difficult it is to recognize faces and do it instantly? Bet you haven't, because it feels effortless. But that's our mind's pattern-latching superpower at work. The same mojo that likes pure geometry for reasons older than the hills. The human brain is evolution's elite pattern spotter, arguably more so than anything else we do. People talk about an organism's environment as water, soil, air. But for most creatures, including us, other organisms are the environment, especially those of our own species. In fact, humans were way more likely to get bumped off by each other than by some lion. That's probably why we've got these ridiculously keen face recognition skills. We can instantly differentiate us from them, even though human faces are practically clones with a few minor differences. And guess what? We see millions of faces over a lifetime without mixing them up, while some alien might see them all as nearly identical. In each face, our incredible brain zeroes in on the essence, so we can recognize it again. We adore caricatures because they amplify the critical features our mind uses to ID a person, like stretching Nietzsche's mustache or forehead to highlight the difference from the average face. In that sense, a caricature can look more like Nietzsche than Nietzsche himself. Likewise, we dig movies because they don't copy reality. Nobody wants raw routine on screen. A decent film captures the most important bits, tossing the fluff. Same for books, games, paintings, any art form. We crave the essence, not the endless details.
Now I feel better.
A huge posse of theoretical physicists think the real world is governed by one consistent, mathematically elegant theory that spawns our vibrant reality, countless phenomena, and a vast history. Plato spelled it out in the Republic. Our world is just a shadow of the real one, the world of ideas. When you say sofa, no specific sofa in mind, and someone else gets it, you're both referencing the idea of a sofa. Every actual sofa you can plop on is just a shadowy imitation of that ideal sofa in Plato's intangible realm. And as you probably guessed, that realm is only accessible to the mind. Sound nuts?
Yes.
Well, physicists took Plato's route further than anyone. MIT's Max Tegmark claims the universe isn't just well described by math, it literally is math. That's basically Plato's legacy in cosmic form. Meanwhile, Sabine Hossenfelder pushes back. These multiverse fantasies, or a single ultimate law of everything, might be beautiful, but they might also be total bullshit.
Bullshit.
And so-called naturalness in physics, she says it's just a beautiful dream, not necessarily the final word, because at the end of the day, our hunger for neat theories doesn't guarantee they're correct. In an interview for the book, the then-living Weinberg, who I recall supposedly didn't care how to interpret the general theory of relativity, responded to Hossenfelder's objections by saying, "I don't know, perhaps the correct theory allows for the occurrence of many big bangs early in the development of the universe. In these big bangs occurring at the same time, the physical constants are very different, and we will never be able to predict what they are in other big bangs from within our own. It is possible that there are an infinite number of explosions at all, and the values of the physical constants in our Big Bang are the ones that just happen to fall into it. If not naturalness, then it's the multiverse. That's how many physicists see it. No supersymmetric particles at the Large Hadron Collider? Boom, multiverse." Meanwhile, we have Ramachandran, a neurophysiologist, pointing out that finding universal laws of aesthetics is a minefield. Sometimes these so-called laws aren't functional themselves, they're just side effects of deeper laws. Even more infuriating? Certain laws can seem contradictory. For example, it would seem that for a heterosexual man, a fully naked woman would be more attractive. But in reality, it is mostly the other way around. It is the partially hidden body that activates our visual centers more effectively and seems more attractive to us. Yes, this applies to both sexes. Why? Because the brain loves a puzzle.
Down, boy!
Perception is basically puzzle solving, so a bit of mystery is exciting, just like the high we get from cracking a crossword or logic puzzle. That little jolt of pleasure is an evolutionary carrot, ensuring we don't give up too soon when hunting or persuading a mate to join us in our cozy cave. Ramachandran's book, The Telltale Brain, was my second Bible while building this video's script. His neurophysiological approach explained the maddening contradictions of beauty, like how our brains both crave coincidences and despise them. Look at the picture. Your brain is saying to you, what are the odds that these three circles with identical cutouts that look like Pac-Man are arranged just so by simple coincidence? How likely is that? It's not bloody likely. It's an overly suspicious coincidence, a fine-tuning. It has a simpler and more general explanation, namely a solid white triangle covering three black discs. That is far more plausible and natural. And you see a triangle.
Did you see it? Did you see what? Wow.
In nature, that, if it's weird it's not random reflex, can be the difference between living or dying. But then you flip the script. A painting is tilted a few degrees on the wall and we freak out. Or a desk drawer won't shut because a paper's sticking out. We get this bizarrely intense negative feeling, or a single piece of lint on an otherwise perfect suit. Why does that bug us? You can blame basic hygiene instincts for some of it, yes, but it's also that built-in hunger for regularity or predictability. We need to order chaos. A crooked painting? That's wrong, and we want to fix it. And this is how Jules-Henri Poincaré sums it up. We see, therefore, that the search for the beautiful leads us to the same choice as the search for the useful. Sabine Hossenfelder dares to say something scandalous. Karl Popper's notion that a scientific theory must be falsifiable is downright outdated. Moreover, in fact, no one in science has ever been able to apply this principle except as a rhetorical device, because it is extremely rare for a theory to be genuinely, actually disproved. Consequently, instead of falsifying theories, we make them implausible. A continuously rearranging theory becomes more and more complex and wiser, if not ugly, and eventually its proponents lose interest in it. How long it takes to make an idea implausible depends on one's tolerance for repeatedly fitting a theory to contradictory data. I'm telling you, she's having fun. Apparently, that's exactly what's going down with the supersymmetry hypothesis right now. So, behold the power of symmetry, a crucial principle our brains latch onto. In nature, important means biological. Prey, predator, potential mate, same species, rival. All symmetrical in form, and that's why symmetry catches our eye and makes us pay attention. Newborns, for instance, will stare at symmetrical ink blots over asymmetrical ones. Their little brains say, "Oh, something symmetrical. It seems important. It's worth looking at some more." Another reason for the allure of symmetry is more subtle. Psychologists showed test subjects a random slew of faces varying in symmetry and found the most symmetrical are rated most attractive, even if the difference is minuscule. Why? Parasites. A parasite infection can reduce someone's reproductive viability, so evolution encourages us to spot if a potential partner's been ravaged by disease. If you got infected in utero or in childhood, you might exhibit small asymmetries. So symmetry signals health and, by extension, attractiveness. Now, is that parasite avoidance mechanism behind Emperor Shah Jahan's symmetrical Taj Mahal, or the obsession scientists have with symmetrical equations? Could be. Our brain might share real abstract pathways, moral disgust, some vile act.
What's that, brother?
And literal disgust, spoiled food.
Oh, shit.
Spark the same areas in the brain. Hossenfelder quips, "Let's look at it this way. My mom likes to say that symmetry is aesthetics for dumb people. What if I told you that a truly beautiful fundamental theory is chaotic and unsymmetrical? Would that sound unconvincing? But it will sound more convincing every time you hear it. Research shows that we believe a certain statement the more often we hear it. This is called the systematic attention error, or the familiarity effect. It's interesting or depressing, depending on your attitude, that this effect occurs even if the statement is repeated by the same person. In fact, chaos is far more beautiful than rigid symmetries. Are you not yet imbued with that statement? Why is a crooked picture on a wall not beautiful, but an off-center mole on someone's face can be weirdly attractive? Possibly we crave a sweet spot between dull order and mind-blowing chaos. Novelty is good, just not too much. You see that formula in life all the time. In school, you instantly know when the teacher's saying something you already get, or something brand new you can comfortably integrate, or something that completely overloads your brain. Once you do manage to puzzle it out, you get that rush of pleasure for taming the chaos. And chaos is exactly where modern physics is right now, or soon will be. These are the rules of the game. If you aim for a theory of everything, your aesthetic taste might be all you've really got. Garrett Lisi, American theoretical physicist. We wouldn't be in such a mess if we only had to deal with universal beauty standards, but oh no, there's another headache. What's beautiful to one person can be unimpressive or downright ugly to another. Why is it that regular folks might feel annoyed when looking at Maxwell's equations, while Nobel laureate Frank Wilczek declares them indescribably gorgeous? Ludwig Boltzmann called them so divine he wondered if God had written them. Meanwhile, 99% of physicists think Einstein's general relativity is one of the most beautiful theories ever, though 99% of people on Earth can't wrap their heads around it no matter how hard they try. into the neural efficiency hypothesis. Studies show that people with higher IQs use less glucose for moderately complex tasks and more for truly tough tasks than lower IQ folks. This suggests that smarter brains deploy their horsepower more selectively. So if you're lucky enough to be super bright, you can find complex ideas playfully easy and see their underlying aesthetic charm, where a normal mortal's mind just sees scribbles on a blackboard. We know every brain loves a sweet spot between simplicity and complexity.
Bullshit.
And guess what? Bigger brains, or just plain smarter ones, relish more
Derivative.
complex stuff.
That I love. I absolutely love.
Ramachandran notes that Einstein's giant angular gyros likely let him merge calculation and spatial abilities in ways most of us can't fathom. He spent a decade wrestling with his monstrous gravity theory. Nobody does that if they aren't enjoying it. As Frank Wilczek put it, if laws weren't beautiful, we wouldn't have discovered them. But here's the kicker. Science, which claims to be immune to human factors, has actually thrived because of them. Question is, can it keep thriving? Hossenfelder points out we already know the world embraces some beautiful ideas, but does it also cradle ugly ones? Maybe we humans are doomed to snag only a bunch of partial truths instead of a single, final theory of everything. Maybe the deepest layer of reality is too damned chaotic for our taste. Many of our unique mental traits likely came from evolutionary repurposing of brain structures that originally did something totally different. Feathers started as scales for insulation. Wings were once forelimbs for walking. Lungs were once fish swim bladders. Evolution does that, pulling an old tool off the shelf for a radically new function. Case in point, language. It got so powerful that our species soared above other primates, basically how life itself transcends raw chemistry. Our craving for science might have sprung from some ancient synergy, but we need to uncover what it is. We must expose our cognitive distortions, our sneaky motivations, and our innate limitations if we want to push forward. To grasp the universe, we've got to grasp ourselves. To grasp physics, we need to grasp biology, psychology, and sociology too. Sure, quantum mechanics works wonders, yet plenty of physicists whine that it's unfathomably weird and, frankly, ugly. Maybe our brains just aren't wired to see microcosmic phenomena as elegant. And is the universe obligated to meet our petty standards of beauty at all scales? Take naturalness, a guiding principle in theory building since the 16th century. Sometimes it paid off, sometimes it was worthless. Look at Andrew Wiles and his proof of Fermat's last theorem. The statement of the problem is famously simple and gorgeous, but the proof? A monstrous 129 pages of hair-raising complexity with zero trace of simplicity. It's not hard to dig up examples in science of beautiful but dead wrong or complicated but actually right. So maybe this beauty-truth link is only inside our heads. Plus, beauty is often personal. Some greatest minds in history vehemently disagreed on which theories to crown beautiful. Take Heisenberg. His scientific approach didn't strike people as beautiful at all. Meanwhile, his contemporary Erwin Schrödinger admitted, "Of course, I was aware of his theory, but I was deterred, if not repulsed, by the very difficult methods of transcendental algebra and the lack of clarity." Then again, Heisenberg had equally harsh words about Schrödinger's ideas, telling Wolfgang Pauli, "The more I reflect on the physical side of Schrödinger's theory, the more repulsive it seems to me. What Schrödinger writes about the visibility of his theory is nonsense."
You're goddamn right.
Eventually, both Heisenberg's and Schrödinger's approaches merged into one quantum theory. Some might say that was the real beauty. But let's jump to a modern example. Cosmologist Paul Steinhardt calls the multiverse pretentious, unnatural, unverifiable, and straight-up dangerous to science. Neil Turok sees it as a total fiasco, while American theoretical physicist Joe Polchinski got so deep into "is the multiverse real" territory, he ended up seeing a psychiatrist. Not a joke. On the flip side, Leonard Susskind finds the notion that our universe might be bigger, richer, weirder, and more diverse positively exhilarating. Bernard Carr warns that the multiverse concept implies a whole new definition of science, so of course it's causing intellectual meltdown. Max Tegmark thinks multiverse haters are just emotionally biased because it shoves us out of the cosmic spotlight. And Tom Siegfried lumps multiverse criticism in with the 19th century types who refuse to believe in atoms. So who's right? Hell if I know. But one thing is crystal clear. What's ugly or beautiful to one brilliant mind is utter nonsense or gorgeous revelation to another. And that's the messy battleground where modern physics currently fights, somewhere between this is crap and this is the Holy Grail. To advance science, we need experiments, hard data. For almost 2,000 years after Aristotle, people assumed heavier objects fall faster than lighter ones. It seemed so obvious. Some of you might still wonder, doesn't it? Then Galileo came along with a cheap demonstration, something a 10-year-old could do, and blew up 2 millennia of abstract wisdom that was purely based on our cozy internal sense of order. Similarly, the total lack of any experimental evidence for supersymmetry is turning its former fans into its fiercest critics. In October 2012, theorist Mikhail Schiffman published a piece basically calling supersymmetry a dead end. He said, we need to ditch it for new ideas, especially so the next generation of theorists doesn't become a lost generation. This echoes George Ellis, professor emeritus at Cape Town, who warned that weakening testability would blast science back 1,000 years. When Hossenfelder interviewed Ellis for her book, he made another point that might piss off half the viewers here. He says, modern scientists grossly overestimate science's limits and have a painfully poor grasp of what science can and cannot do. For instance, if Stephen Hawking claims God didn't create the universe, is that really a scientific statement or just philosophical? Where's the data? Similarly, Victor Stenger wrote a book claiming science disproves God, but didn't exactly detail the lab experiment that spat out God equals 0. So what does Stenger mean by science? Or take Lawrence Krauss, self-appointed ambassador for science, strutting into a debate on God's existence and capping it with an empty glass stunt to prove the nothingness from his book. Points for showmanship, maybe. Points for actual scientific evidence? Let's just say 0. There's nothing wrong with believing or not believing in God. Everyone's free to a metaphysical stance, including scientists. But if you're claiming to prove your position scientifically, you better have logic and data. Since David Hume, over 250 years ago, we've known science can't prove or disprove God. Krauss moans when his debate opponent uses rhetorical flourishes, but that's exactly what he's doing too, just from the science side. It's basically an example of how modern scientists' scorn for philosophy leads them to try reinventing the wheel. On top of that, they rely unconsciously on criteria like beauty in their grand theories. George Ellis is one of the rare voices in Hossenfelder's book that she fully respects. She thinks hooking physicists up with top-notch philosophers and training them to spot basic cognitive pitfalls could catapult science forward. Because, as Feynman said, it doesn't matter how beautiful your theory is, it doesn't matter how clever you are. If it doesn't agree with experiment, it's wrong. Women choose. Sexual selection has shaped the evolution of almost every species on Earth, especially humans. Our bizarrely huge brains, likely a product of sexual selection. Why else would we have way more processing power than needed to survive on the African savanna? Our ancestors 100 millennia back could in principle grasp quantum mechanics as well as we do. Why? One theory says our braininess is humanity's version of a peacock's gaudy tail. Think about those elaborate pufferfish nests and bowerbird huts, or the dancing, crooning birds of paradise. It's the same principle. The female adores flashy displays, be they artistic or intellectual. Cue the cliché, girls swooning for musicians and artists.
You serious?
Sure, humans are more complicated, but the basic principle, not that different. Once upon a time, some proto-human female fascination with high intelligence was so strong they were prepared to risk dying in childbirth for the chance of having the big-headed offspring of a super-smart male. It's an overstatement, yes, and the process was more gradual, but it was still lightning fast by evolutionary standards. which is why giving birth for humans is insanely risky. Huge brains, huge costs. That's nature's messy solution, far from elegant. Before you jump down my throat,
Tell him, Wash.
in our society we often assume men choose women, but biologically, females typically do the choosing. Why? Because for females, reproduction is riskier and more resource-intensive. The number of children that one woman can have is very limited. A man can sire an entire battalion. So even in a population 50-50 men and women, from the female perspective, there's a glut of men per woman. Men propose, women dispose. Some guys get chosen, others get tossed aside. This is reflected in the fact we have significantly more female than male ancestors. In Is There Anything Good About Men?, Roy Baumeister cites studies showing humans have twice as many female ancestors as male ancestors. A massive chunk of men who ever lived left no descendants at all. You might be thinking, but men and women exist in roughly the same numbers. Right. But on average, pretty much every adult woman in history had at least one child, while some men fathered kids with multiple women, and the rest fathered none. Obviously, the math wasn't neat, but it gives a sense of how sexual selection hammered us into shape. Evolution experiments on males, because one lucky male can father loads of kids, while that's not possible in reverse.
Women.
And that, so the argument goes, is how we ended up with near mystical levels of intellect. Yes, it's females choose, but don't imagine it's some deliberate, rational process. Think a female pufferfish is thoughtfully comparing nest designs? She just sees something that triggers her instincts. Same with humans. People massively overestimate how conscious we are in these matters. Girls don't know why they fall in love. It's beyond their control. And fellas, if you think every girl is searching for some perfect, platonic, ideal man that can't possibly exist in the gritty real world, buddy, maybe check your illusions at the door. Guppy fish offer yet another baffling example of beauty in nature. Females go crazy for blue markings on mates, even though guppies aren't blue at all. It's just some weird neural quirk. But guess what would happen if a random mutation turned one male guppy blue? You could bet the next few millennia would see a thriving population of flamboyantly blue guppies, an absurd color with no survival advantage purely because the ladies dig it. Females pass down both the appealing traits and the preference for them to offspring. Of course, natural selection is still the final judge. If a species goes too far in chasing silly aesthetics, it can wipe itself out. Case in point, the saber-toothed tiger. One theory says their comically oversized fangs were mostly for show, meant to impress females. Then came the Ice Age. Their big prey buffet vanished, and those giant teeth were useless for hunting smaller game. End of story. On the flip side, if a species persists, it means it's latched onto something real about the world, something that keeps it going, like our structures that stay standing because they're grounded in a deep theoretical framework. That doesn't mean our theory is complete. If any species were a complete unified theory of reality, it'd live anywhere forever. We might be stuck in fundamental physics precisely because we're hitting the ceiling of what the human brain can ever grasp. Who knows how far our genes can take us into the universe's core secrets? But given Homo sapiens is the planet's top success story, thanks in no small part to women's selective preferences, maybe we can still push forward a bit further. David Hume famously said, "The cause or causes of order in the universe are likely to have some remote analogy to the human mind." So, did you piece the puzzle together? Then that's it for now. Thanks for watching.
That was easy.